We have to evaluate the given limit, and here we're going to use Taylor series expansion of sine of x. So that's equals to summation from starting from 0 to infinity of -1 to the power of k times x raised to the power of 2k plus 1 and over factorial of 2k plus 1. And also we're going to use Taylor series for an inverse tangent of x. So that summation started from 0 to infinity of -1 to the power k times x to the power of 2k plus 1 and over 2k plus 1. So now limit as x approaches to 0 of sine of ax minus inverse tangent of ax over bx cubed equals to limit as x goes to 0 of Taylor series expansion of sine of x, sine of ax. So that's summation starting from 0 to infinity of -1 to the k times ax to the power of 2k plus 1 and over factorial of 2k plus 1 minus summation starting from 0 to infinity times of -1 to the power of k times ax to the power of 2k plus 1 and over 2k plus 1. And this whole thing over bx cubed. So that equals to limit as x approaches 0. And here we're gonna take out a common factor, which is summation starting from 0 to infinity of -1 to the power of k times ax to the power of 2k plus 1 and multiply by 1 over factorial of 2k plus 1 minus 1 over 2k plus 1 and over bx cubed. So now to convert a summation notation into sum, we're going to substitute the values from 0 to infinity. So we get limit as x approaches to 0 of, at first we substitute zeros, that's going to be -1 to the power of 0 times a to the power of 2 times 0 plus 1 times x to the power of 2 times 0 minus 2 and times 1 over 2 times 0 plus 1 factorial of 2 times 0 plus 1 minus 1 over 2 times 0 plus 1 and over b plus, now we substitute 1, so that's -1 to the power of 1, then a times a to the power of 2 times 1 plus 1 times x to the power of 2 times 1 minus 2 and times 1 over factorial 2 times 1 plus 1 minus 1 over 2 times 1 plus 1 and over b, so that's plus, now we substitute 2, so that's going to be -1 to the power of 2 times a to the power of 2 times 2 plus 1 times x to the power of 2 times 2 minus 2 and 1 and times 1 over factorial of 2 times 2 plus 1 minus 1 over 2 times 2 plus minus 1 plus 1. And then it just continues and here over b. So by after simplifying we get limit as x approaches to 0 of ax to the -2 times 1 over factorial of 1 minus 1 over 1 and over b minus a cubed x to the 0 power times 1 over 3 factorial minus 1/3 and over b and plus a to the 5th power x squared times 1 over factorial of 5 minus 1 over 5 and over b. So that equals limit as x approaches to 0 of 0 minus a cubed times -1/6 over b plus a to the 5th power times x squared times 1 over factorial of 5 minus 1 over 5 and over b. So now we're going to plug in the value of limit into the series. So that's going to be 0 plus a cubed over 6b, and if here we substitute 0, we get just 0, and then it just continues be 0. So that's equals to a cubed over 6b. So that's going to be our answer.